we have this piecewise function. Let's evaluate. How do you do that? You simply think when x equals 2, you want to plug in 2. Question is, where do you plug in the 2? It all depends on your condition. So is 2 less than negative 2? Is 2 less than negative 2? No. So when you're plugging in 2, you're not going to use this first one. Is 2 less than 1 or greater than or equal to negative 2? Is the number 2 in between the negative 2 and the 1 on a number line? No. So you're not going to use the second one. Is the number 2 greater than 1? Yes. So you're going to use the third one, ladies and gentlemen. So for number 5, it says evaluate when x equals 2. Well, 2 is greater than 1. You're going to use this one. And let's work it out right now in our heads. What is negative 2 times 2? And negative 4 plus 3? Negative 1. So the answer number 5 is negative 1. Okay? And you should probably write it in the notation g of 2. G of 2 equals negative 1. Sorry, that's all sloppy. But g of 2 equals negative 1. Okay, let's move on to the next one. It's saying g of negative 2. So where are we going to plug in negative 2? Are you going to plug it into the top one? No. Are you going to plug it into the middle one? Yes. Negative 2 is definitely less than or equal to negative 2. Because of that little line on the inequality, you know that negative 2 is equal to negative 2, so you're going to use this one. Now, if I do plug in a negative 2 right in there, what do I get? Positive 4, and that's my answer for number 6. For number 7, let's plug in negative 3. The question is, where do we plug it in? Is negative 3 less than negative 2? Yes, it is. So we're plugging it into this one, but there's nowhere to plug in anything. The answer is just 4. How about number 8, g of 4? Where am I going to plug in 4? Do I plug it into this one? Is 4 less than negative 2? No. Is 4 between negative 2 and 1? No. Is 4 greater than 1? Yeah, so we're going to plug in a 4 right here. It's going to say negative 2 times 4. What's negative 2 times 4? Negative 8. And what about negative 8 plus 3? Negative 5. So g of 1, oh, I'm sorry. I put in the wrong spot. G of 4 is negative 5. Guys got it? Now, how about g of 1? This one's a little tricky. Am I going to plug in the 1 right here? Is 1 less than negative 2? No. Is 1 less than 1? Yes. Is 1 less than 1? No. No. It's equal to 1. Is 1 greater than 1? No. So, what the heck? According to this function, g of 1 is undefined. It's undefined. Because you can't plug in 1 anywhere. You just can't do it. It doesn't make sense. Right? It doesn't meet these conditions. Okay? Moving on to g of 0. Where am I going to plug in 0? Do I plug it into the first one? No. Do I plug it into the second one? Yes, 0 is between negative 2 and 1. So when I plug in 0 here, 0 squared is what? 0. Okay, we're good. Let's move on to the more fun part of this, which would be graphing g of x. Now, if we take a look at our first piece, that is simply a constant value 4. That's saying y equals 4. Now, y equals 4, Cameron, is a line at the y equals 4 value. So my line at the y equals 4 value is right here, and it goes in both directions. However, the restriction is that you're looking at the x values that are less than negative 2. Now, if you think about that, I'm going to erase it already. Negative 2 would be right there. So you're only looking at this piece of it. Why is that? Because when you think of x as less than negative 2, here's the negative 2 line on the x. Where's less than negative 2? Is it to the left side of this or to the right side of this? To the left. Less than's to the left. That's why we're only showing this piece of that line. And it doesn't have an or equal to, so it's not a solid dot. It's going to be an open dot right there. Let's move on to the next piece. The next piece is what? X squared. And what does that look like? Does that look like a line? No, that's a parabola. Ladies and gentlemen, it's the easiest type of parabola. It's actually the parent graph of all parabolas. It has the vertex. It has the vertex at 0, 0. And then you could use the pattern of A equals 1. That would be 1, 1, 2, 4, 3, 9. So you have 1, 1. You have 1, 2, 1, 2, 3, 4. It lands perfectly in that open dot. And if you connect these, and if you reflect them onto the other side, it would also be right here and over here. However, I better stop drawing this. I need to look at my restriction first. They want us to look at the x values that are between -2 and 1. So -2 is right here, and 1 is over here. So I don't want to draw this too far out this way because I want to stop at the x value of 1. Does that make sense? So it's going to end up right here. I hope this makes sense to you guys, because the x value of -2 is right here. Whoa. The x value of -2 is right here. The x value of 1 is right here. So you're only wanting to look at this piece of the parabola. So it's going to stop right there. And it's an open dot at x equals 1. And then moving on to our third piece. That third piece is a line, y equals mx plus b. It's y equals -2x plus 3. And what do we know about that? It's going to cross at 3 right there. And then you look at the slope, which is -2 over 1, which means you're going to go down 2 over 1. And you end up at that open dot. And then you keep going down 2 and over 1, and you end up right here. And then down 2 and over 1, and down 2 and over 1. But before drawing this entire line, you want to look at the restriction, and it says x is greater than 1. So here's 1 on the x-axis. You want to look at the values that are greater than 1. So you want to look at the right side of this line, x equals 1. So you want to show this piece of it. You don't want to go this way. You want to go this way because it's saying x is greater than 1. So if I do show that, now remember that's an open dot. It's not a closed dot, because this inequality says x is greater than 1, not greater than or equal to. So it's still an open dot. Now that makes it a little weird because the whole function is continuous. It's filled in. And then right here you get to an open dot, and then you go down. This is an open dot, which means that it's undefined at the x value of 1 because there's no coordinate.